5 light years away. The same journey at the speed of today's spacecraft would last 100,000 years. As we cross the perpetual night, our voyage takes us up and out of our sun's neighborhood, near the edge of a great pinwheel of stars.
Swinging, they're up and down.
There's clouds in space. Clouds in space. There's clouds in space. There's a star so much.
Is that the Milky Way? What is that? What is that?
It's beautiful.
Look at that. That's not like they're clouds, oh my god, but they're
The
stars.
Milky Way is actually a spiral galaxy.
How many
And our own
dogs
sun is just one of 100 billion stars in it. At this immense scale, 23 powers of 10, each shining light we see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding.
I'm starstruck.
Our own galaxy and all the others form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this boundless horizon,
Pressure, Lisa.
we cannot see and do not know.
Pressure, Lisa.
While Galileo's telescope allowed us to take an outward voyage, another innovation here in the Dutch town of Delft would lead us on an inward journey of discovery. Over 3 centuries ago, Antony van Leeuwenhoek perfected the early microscope and used it to study droplets from the waterways of Holland.
Microscope.
It's through their window. What a nice house. What a nice house. The window.
Get there. Come in here.
Come on.
As students today make their own discoveries, imagine the moment when Van Leeuwenhoek peered through his more powerful instrument and discovered a living kingdom in a drop of water.
Can I kill it?
Lick it with your life.
Lick it with your tongue. Don't even think about
This
it.
busy world of single-cell paramecia is only 1 millimeter across, 3 powers of 10 smaller than a meter.
Let's put in a
The
saw.
microscope allows us to continue our journey
Saw?
to the realm of the very small.
Skull.
As we move into the cell nucleus, each new ring now reveals a world 10 times smaller in diameter than the last.
Wow. Say goodbye.
Deep within the nucleus, we come upon truly remarkable constructions. Long, spiraling molecules.
Oh, here comes the circles of life.
DNA holds the chemical codes for the reproduction of most organisms on the planet,
DNA's.
whether they're paramecia, people,
This twisted
or
ladder.
petunias.
You have a twisted mind. Thick and
Voyaging on,
mind.
we see that molecules are made
Shake
of even
them
smaller
around.
parts
Shake
called
like
atoms.
Sit right back here,
The tiny world of the carbonate is very strange indeed. Its 6 electrons seem to swarm everywhere at once. Now our voyage takes us through a void that appears as vast as the space between the stars. Ahead lies the atomic nucleus, so fantastically small that if the whole atom were the size of this theater, its nucleus would be like a speck of dust. Yet the nucleus contains almost all of the atom's mass, packed into particles called protons and neutrons. And these, in turn, are made of still smaller, mysterious things called quarks. Exploring this, the inner frontier of the universe, physicists wonder if quarks might contain even tinier building blocks of matter.
You're going live again.
Scientists are investigating this mystery in an underground tunnel near Chicago, home of the giant Fermilab particle accelerator, designed to create conditions like those that existed just after the birth of our universe.
Look at that. So modern.
Millions of protons and antiprotons race through these pipes in opposite directions, nearly at the speed of light in a kind of subatomic demolition derby.
Oh, go too fast. We're gonna get this now.
Imagine I was streaming.
I felt like I was there.
Now, our cosmic voyage enters another dimension,
How did you do it like this?
the dimension of time, where knowledge is much less certain. Studying traces of quarks from these collisions, physicists try to learn what our universe was like when it began after the explosion known as the Big Bang.
Big Bang. Big Bang.
One of them outlines the theory.
Bang.
Welcome to Fermilab. Today, astronomers see the universe expanding.
Sorry.
Imagine running the expansion backwards. Billions of years ago, everything must have been packed together at enormous density. It seems incredible, but we think that the matter making up everything we see in the universe today, everything, the buildings, trees, people, planets, stars out to the most distant galaxies, was once crammed together into a volume smaller than this. And then,
Here.
This is how this is the Big Bang Theory, guys. They think that it was all in a little thing about the size of a golf ball, and that exploded and made everything.
It made everything?
Like,
Like,
those
how
first
much is
dazzling
that?
moments, the newborn universe began to expand.
Fine.
Quarks combined into protons and neutrons, which later attracted electrons to form atoms, and the vast fall lifted. For hundreds of millions of years, the force of gravity slowly drew matter together into a gigantic web, the architecture of the cosmos. Two billion years passed. Clouds of gas and dust condensed like giant water drops along the cosmic strands and formed galaxies.